All right, so Stephen, if you're listening to the recording, we just finished the actual mock exam. Make sure you take a short break first before you continue. So now I'm going to go through the questions from this exam. So Peter, say that again. Like, what do you think is the difficulty of this paper out of 10?
So I don't think it's 7.5.
7.5. All right. So Stephen, see if you also feel the same. All right. So moving on, question 1. The steps for question 1 is very basic. 1A is very basic. The idea is to change it to the same base. So the same base will be 4, right? Maybe I'll just write the proper working here. So 16 power x equals 1024. And that will be 2 power 4 times x, right? Because that will be 2 power 4 everything power x, which is 2 power 4x equals 2. Now 1024, if you don't know exactly what it is, then you can just use the factor tree. So the steps will be the factor tree. 5 and 12, that'll be divided by 2, 256, divided by 2 again, 128, divided by 2 is 64. Let's keep going. If you get to a number that you recognize like 32, you can write that as 2 power 5, for example, right? Then we know that the power here, so that's 5 2's in here, that'll be 1, 2, 3, 4, 5. 5 2's in 32, and then that'll be 6, 7, 8, 9, 10. So that'll be 2 power 10. So then you get 4x equals to 10, and x would be 10 over 4, simplified to 5 over 2, which is 2.5. Okay, so that should be the final answer. Make sure you check your answer and put a tick if it's correct. Yeah, or 5 over 2 is fine too, either way. All right, so question B. So for question B, if you see that, you should notice that this one has one term on the left hand side, one term on the right hand side, and then the idea is the same, convert to the same base. 5 power 2n times 5 squared, and then everything to the power 2n minus 1 equals to 625, same strategy. Divide by 5, then you get, just divide digit by digit, 6 divided by 5 is 1, remainder 1, 12 divided by 5 is 2, remainder 2, and 25 is just that. If you notice, 125 is just 5 power 3, but you can keep going. So 5, 25, and then 5, 5. So 6, 25 is 1, 2, 3, 5 to the power 4. Okay? So then so this one would be 5 to the power 2n times, and then you times this 2 into each of the term in there. That will be 5 to the power 4n minus 2 equals to 5 power 4. Alright? So when you multiply two powers of the same base, you add them up. Plus 4n minus 2 equals to 5 power 4. Now you've got both will be the same base, so the two powers must be the same. So then 2n plus 4n minus 2 equals 4. Alright, and then after that, just solve for n. 6n, move the 2 over, equals 6n equals 1. Alright, that's the final answer for question B. Okay, and then for question C, for C, you've got ln x plus ln of 2x minus 1 equals to 0. When you plus two log functions, two log expressions, you're just multiplying what's inside. So ln of x times 2x minus 1 equals to 0. And now you need to do the whole base e. So that's ln is log base e, right? Base e raised to the power 0 equals to this. So then you've got e power 0, which is 1, but I'll write it here, equals to that. Alright, so then e power 0 equals to 1, that will be 2x squared minus x, and it looks like a quadratic, so let's just solve it. Move the 1 over, so that will be 2x squared minus, actually I'll write it this way, 2x squared minus x minus 1. This is not a monic quadratic, but you can try to use the ACB table or the times plus table. Let's call that ACB table, right? So A times C is 2 minus times minus 1 is minus 2, and then B is negative 1. So factors of minus 2 add up to negative 1. So that would be minus 2 and positive 1, right? Not a monic quadratic, so you have to split the middle term up, minus 2x plus x minus 1. Take out common factor, which is 2x in the first two terms here. That would be x minus 1, and then you want the x minus 1 in the second term, so you just take out 1. Right? So once again, I encourage you to write the common factor 1 that we are taking out here. Right? Just to remember that when you take the x minus 1 out, it's just going to be 2x plus 1. If you don't write the plus 1 here, some people in the stress of the exam they forget and just put 2x, which is wrong. Alright, so then you've got x minus 1 equals to 0 or 2x plus 1 equals to 0. So x equals 1 or x equals minus 1 over 2. Alright, now let's have a look at this question here. You have got ln x. So when you see log, right, and then x inside it, be very careful. When you have ln x, you can't have negative numbers. So this one is actually rejected. If you don't reject this, you will lose a mark because your final answer is incorrect. The final answer is only x equals to 1. Okay, this is the only final answer. If you put both, you'll get marks deducted. Did you?
I got it right.
Okay, good. All right, next one. So that's it for question 1. Okay, all of question 1 are simple familiar. So Stephen, if you are let's see, if you are listening to this recording before having finished the paper, you won't actually get the solutions sheet yet. But yeah, so when you get the solution sheet, it will tell you which chapter and what's the complexity of the question. Okay. All right. So moving on, question 2. Determine the derivative of the following functions. The first one is just a simple chain rule. Okay. Question A, f dash x would just be simple chain rule. Bring the power down, minus 3, 1 minus x squared, drop the power by 1 minus 4, and then times by the derivative of what's inside, which is this thing there. So then you've got 1 is 0, so that minus 2x. Okay? Equals to, so minus 3 times minus 2 is just 6. So that would just be 6x on top, and then 1 minus x squared, everything power 4. And this is the simplest one. So that's just the final answer there. All right, question B. F dash of x would be, now before I do f dash of x, I actually want to convert fx. So note this is fx, yeah? Fx equals to e to the power x to the power 1/2. Right? Convert that to fractional power first, and then you derive it. So note that the inner function is this thing there, right? That's the inner function. So then you would derive it, bring e to the power anything, it's just the same, right? Power 1/2, and then you derive the power, times that in. So you derive x to the power 1/2 is 1/2 x to the power minus 1/2. All right, when you subtract the power by 1, you get negative 1/2. So then convert all of the weird numbers into like the weird power, like the fractional power into square root. That will be e power square root x times by 1/2 times 1 over square root x. Okay, so then the most simplified answer would be e to the power square root x over 2 square root x. You gotta get to this final answer there. Alright, did you get that one, Peter?
Got that one wrong.
What a shame. Need more practice. The tricky bit is when you have fractional power in the power. So this is definitely not an easy question. But anyway, this question is actually could be in your exam because it looks simple, right? It's just e to the power square root x. It looks simple. It's actually not that simple. So question F, fx is equals to 2x squared ln x. I would write this because then I would want to, in the exam, if you're confident, you can derive it straight away as long as you know this is u, that's v, right? Otherwise, you can just go u dash, v dash, but I'm just gonna straight to the answer. So f dash x would be, I'll write the formula down first, u dash v plus u v dash. Okay, so u dash would be 4x, v would be just ln x, plus u is 2x squared, v dash is 1 over x. Alright, so I'm used to seeing this, so I can just get straight to this one. I can check the u v dash, v dash quickly. Alright, so at this point, you want to take out the, okay, let's see how do we simplify this? 4x times ln x plus, so 1 over x and 2x squared, so we can just simplify that, would be plus 2x. And I think that's the simplest one. If you want to take out the common factor, like this is optional, so 2x and then you've got 2 ln x plus 1. I'm actually not sure whether this one would be considered more simple than the other one, but when you take something out and it doesn't really simplify, then I normally wouldn't actually do it like this. Alright, so let's just leave it in this form here.
Or can you check my one? Because I took out the x index negative 1.
That's not simplified. You're supposed to, the x to the index -1, you're supposed to times that into 2x squared to cancel out the over x. Yeah, so that's definitely not the simplified version. Okay, question D. So question D is sine 3x cos 4x. Fx equals to sine 3x times cos of 4x. This one's not too bad as well. It's just the chain rule again. So f dash x equals to u dash v plus u v dash. So u dash would be sine becomes, if you want, okay, if you're not comfortable doing the sine 3x derivative straight away, then you probably should write the u equals to sine of 3x and then v equals to cos 4x. And then derive these two separately. So v dash would be, now that's a chain rule here, right? So cos becomes negative sine and then you gotta times it by the coefficient of x. When you derive what's in here, you get 4. So that's minus 4 sine of the same thing, 4x. So this one would be 3 cos of 3x, okay? So it's a chain rule. Alright, so if you're unsure, make sure you do the derivative first before you actually combine them. So then that would be u dash 3 cos 3x, v is cos of 4x, plus u is sine 3x times v, v dash, which is minus 4 of that. So the most simplified version is essentially just move that to minus 4. And then you've got sine 3x times sine 4x. You can't actually simplify anything further, so I'm pretty sure that's the final answer. Okay, you change it to the minus 4. Yep, that would be the most simplified version for that question there. Alright, any question, Peter? No? Okay, question 3. Determine the exact value of each of the following definite integrals. So, okay, so I'll just, let me see, I'll probably just work this one out. It's not too hard. So that one would just be, when you antiderive it, is 1/4 x power 4 plus 2/3 x power 3 plus 1/2 x squared plus 2x. Calculated between 0 and 2. So note that when you sub 0, you just get 0, right? So it's essentially you need to sub 2. Equals to, sub 2 in there is 1/4 times 16 plus 2/3 times 8 plus half times 4 and then plus 2 times 2, which is 4. Alright, and let's keep going. So that would be 4 plus 16 on 3 plus 2 plus 4. Add these ones up, you get 10. So essentially it's just 10 plus 16 on 3, which is, well, you can use the mixed number. Let me just double check the answer. Oh yeah, they use a mixed number. Okay, so because 16 on 3 is an improper fraction, you can convert that to a mixed number. So that's just 5, 1 on 3, which is 15, 1 on 3. Okay, so that would be the final answer there. Right. Well, if you have like something like 46 over 3, I think that would be okay too, because they don't exactly mention that you need to use the mixed number version. So either way is okay. Alright, 46 over 3 or 15, 1 over 3. Now for question B, probably need more space for this one. 0, 1 of 2e power x over 3 plus 2 dx. Anti-deriving this, you would get, actually, I would take out 2 first, right? I'll take out 2 first and then antiderive only what's inside. So that's 2, let's rewrite that, e to the power 1/3 times x, so I know what the coefficient of x is, plus 1 dx. Alright, so that would be 2 times, and then antiderive e, you get the same thing, but then you need to divide by the coefficient of x, which is 1/3, divide by 1/3, divide by 1 over 3 is the same as times by 3 over 1, which is times 3. So that's just 3 times that plus x calculated between 0 and 1. Okay, so then that would be 2 times, sub 1 in first, we use this bracket, sub 1 in, that would be 3e power 1/3 plus 1, and then subtract sub 0. So that would be e power 0 is 1, so that's just 3 and then plus 0. Okay, keep going. So that would be 2 times, brackets, open the brackets up, will be 3 e power 1/3 plus 1 minus 3. And that would be 1 minus 2, which is minus 2, times the 2 back in, that would be 6 e power 1/3 and then minus 2, so that would be minus 4. Yep, that's the final answer. Okay. All right. Last one. Okay, this one. Find the derivative of this and hence evaluate that. This is, as you can probably guess, this is a complex familiar question. Right? This is like a transition kind of. Okay, so this is a complex familiar question and you just derive e power square root x. Actually, remember we did that before? It was like up here. Alright, derive e to the power square root x, so we already got the answer, which is this one there. I'm just going to use that. Alright, so if you guys get a question like that in the exam, you'll be pretty lucky. You can just reuse that straight away. Okay, let me try to find that. Okay, question C. Alright, so that will be the answer for the first part. For question C, so d over dx of e to the power square root x should be equals to this. Okay, now let's see, hence evaluate this thing. Alright, let's see, so evaluate antiderive of 1 to 2, 1 to 2 of e to the power square root x over, let's see, just 1 square root x dx. Okay, what are we missing here?
2.
The 2. Yep. That's right. So then this one would be equals to, the trick is to go, because you want 1 over 2, so I put 1 over 2 closer to the antiderivative, right? So times that in. Let me. Okay, so times that in, that would be, the rest will be the same. You have to keep writing this stuff here. E power x over square root x dx, right? So the trick is times 2 times 1 over 2, so that it's still the same. And then when you times 1 over 2 inside it, that would be just the 2 on the outside. And then inside the brackets is what you found from the previous question, over 2 square root x dx. Okay, now this is the same as that, which means when you antiderive, you would get 2 times square brackets from 1 to 2, and what goes in is the part that we tried to derive before, this thing here. So that will just be e to the power square root x. Okay, and then just sub 2 and 1, so that will be 2 times by e power square root 2 minus e power 1. And yep, that's just 2e to the power square root 2 minus 2e. Final answer. Did you get this one, Peter?
No, I got the other one wrong, so.
Okay, yeah. Oh, right. That's why you wouldn't be able to do this one, right? Yeah. So go back, try this one again. Okay. Right, moving on. Question 4. This one is actually still a simple familiar question. Okay, because this the only concept. This is a slightly harder simple familiar, but it's supposed to be still an easy simple familiar because it's easy. Two concepts: log equations and simultaneous equation. Literally, that's it. So sub the 2 points in. When you see find a and b, string simultaneous equations, sub 8, 10, then you would get 10 equals to a log base 2 of 8 plus b. What's log base 2 of 8?
3.
3, correct. The idea is 2 raised to what number equals 8? The answer is 3. So that's 3a plus b. If I see a and b, I'll think about simultaneous equation. Normally, I would try to use elimination, so I won't define this one yet. I'll just work the other one out on the side first. Sub 32, 14. Okay, so 14 equals to a log base 2 of 32 plus b. What's log base 2 of 32?
It's 5.
It's 5, correct. Alright, just to clarify any confusion, so that will be log base 2 of 2 power 5. Take this one, bring out to the front, so that would be 5 log 2 log 2 equals 1. So that would just be 5 times 1, which is 5. So then that would be 14 equals to 5a and then plus b. Okay, now note these two equations. Am I able to do elimination straight away?
Yeah.
Yes, that's right, because I see that there's 1b here and know that this is plus b, yeah? So 1 plus b, 1 plus b. So I can eliminate by, what's the method? Normally it's division or subtraction. Which one?
Subtraction.
Subtraction, that's right. Subtract. Okay, which one was subtract? 1 from 2. Right? So you start with equation 2 and then you subtract equation 1. That's why subtract 1 from 2. So that will be 14 equals to 5a plus b. I do this because I don't want to get negative numbers, right? So subtract the other one, which is smaller. 3a is also smaller. Plus b cancel out. That will be 0. So 5a minus 3a is 2a equals 4. So a is 2. Done. Right? Next, sub a into I'll call this one equation 3. Sub 3 into any equation. I'll choose equation 1 because that's easier. Then I'll get 10 equals to 3 times 2 plus b. So 10 equals 6 plus b, and so b would be 4. Okay, so these are the two answers. So the final answer, a equals 2, b equals 4 is the final answer. Okay, did you get that?
I'm gonna change this one because
Yes, you're supposed to have to be able to change it. Log 2 of 8 is 3. Yeah, so you have to actually change that, otherwise you won't get the final answer. Okay, moving on. Question 5. Let me just change.
I don't know how to do question 5. I remember like we did before, but
Okay, let's see. So okay, I'll just use intuition, right? I won't go exactly how I know how to do it. So in the exam, you when you see this question, this is a complex familiar question. So you'll be like, I don't know what to do. Keywords, tangent. First thing you do, derive. Right? When you see tangent, you derive. So let fx equals to x squared plus 2x, as I like to use the f dash x notation. So f dash x would be 2x plus 2. Even if you stop here, you probably would get half a mark to 1 mark just because you're deriving it and you're finding the tangent. Alright, so tangent at the point a squared plus 2a passes through the origin. Okay, so we've got a point here. And then it passes through the origin. So let's think about what that looks like. So x squared plus 2x, again, this is an easy question, okay? It's some sort of a quadratic. If you don't know exactly where it is, that's fine. Just know that it's a quadratic. And then a squared plus 2a, I don't know, let's say it's here, right? That's a and a squared plus 2a. Whichever that one is, then they're saying that this one has to pass through the origin, which is I don't know, let's say here. All right, so this tangent passes through the origin, which is 0, 0. Now, when you think about this, right? If it passes through the, so now that we've got, you've got the definition of the tangent, and then we've got that it passes through 0, 0. Most of the time, if you're solving for something, find the value of a, you need to find an equation, some sort of an equation, right? And to find an equation, you need left-hand side, you need some idea of left-hand side equals right-hand side, right? And then you can solve for a somehow. Now, what can we get as a left-hand side? If you get a tangent, you can calculate one of the ideas, which is gradient of the tangent, right? Because this is the gradient function. Remember, the concept of this is the gradient function, right? Okay. So now, if we can calculate the gradient of that tangent, and we can do that, right? So at the let's just see. Let's think about it. So at x equals a, the gradient of the tangent would be equals to f dash of a. Does that make sense?
yeah.
Yeah, and that would be 2a plus 2, right? Okay, so this would be the left-hand side because this is the gradient. Is there another way to calculate gradient that uses the value 0, 0 here? Remember, gradient is, another way of thinking about gradient is rise over run. Okay, or it would just be like y2 minus y1 over x2 minus x1. That's another way of calculating gradient. Sometimes you might forget about this, but hopefully you don't. Yeah. If you do enough questions, you'll recognize this. So you see, this is also the gradient. You see, these are two ways of calculating the same thing, which is gradient. This is one way, and this is another way, right? So the other way to calculate gradient would be equals to then y2 which is a squared plus 2a minus y1 which is 0, and then x2 which is a minus x1 which is 0. Look, we've got something that looks different from the first way of calculating gradient, which means this one, now I can see, oh, this one is the left hand side, this one is the right hand side. Okay, now that I've got these two, I just equate them. So this is one way of calculating gradient, and then the right hand side, this is another way of calculating the gradient. Minus 0 is just the same thing over a. Now it's going to solve this.
Yeah.
Right, okay, let's see, a plus 2.
I think you need to take out the a.
Yeah, but okay, hang on, let me see. Oh yeah, that's right. Yep, so times a over, so you got 2a squared plus 2a equals to a squared plus 2a. Okay, and yeah, this question is a bit strange because it's quite easy at this point. You can just cancel out the plus 2a on both sides and then bring the a squared over. So that would be 2a squared minus a squared equals 0. A squared equals to 0, so a equals to 0. Oh, interesting. Ah, I see. At the point 0 and then 0 plus 0.
Yeah, 0.
Yeah, so they're saying that the only tangent, let me check the answer. Yeah, a equals to 0. So the only tangent that passes through 0 is the tangent at the origin. Because this graph goes through 0, 0. So this graph, when you sub x equals to 0, you get y equals to 0.
Yep.
So it looks something like there will be 2 x-intercept, 0 and minus 2. How did I know that? Well, y equals 2. Take out x plus 2, right? When you sub y equals to 0, x must be 0 or negative 2. Okay, so for y to be equals to 0. You see that? Yeah? Which means that, and this is concave up, so it looks something like that. So what they're saying is, the graph looks like that, and the tangent, that is the tangent at the point that goes through the center, is the only tangent that does that is the tangent at 0, 0. Looks something like that. Well, all the other tangents will not go through the origin. Okay, the only tangent that goes through the origin is at the origin itself. So strange question, but mathematically it's the concepts are the same, right? So once again, remember when you're solving for something, normally in a hard question, you need to define two ways of finding that thing, because you need to do an equation to solve it, right?
I could remember that one.
Yeah, so just remember left hand side equals right hand side. You need some way of finding it and another way of finding it, and then you equate them, right? Because to solve for something, you need an equation. So yeah, so you need to find a way to get that equation. That's the only way for you to be able to do it. Okay, next would be question 6. Find the position and nature of any stationary point. So what's a stationary point? How do we find stationary point? F dash equals to 0. So you need to find f dash first. 1 and then derive this thing, that would just be minus e to the power minus x. If you don't get the f dash x right, you can't do the next two ones. So stationary point, start point, therefore implies that f dash x equals to 0. So you get 0 equals to 1 minus e power minus x. Bring the e over, e power minus x equals 1, and then you get yeah, so the only one is the only answer is 0, or you can go minus x equals to ln of 1, which is 0. So minus x equals to 0, so x must be 0. That's the only answer. Okay, now we've got the stationary point x equals to 0, and then you got to find the position, right? Position means that you need the y value as well. So the y value is f at the x value 0, which is 0 plus e power minus 0, which is 0 plus 1, which is 1. Okay, therefore stationary point at 0, 1. Now we need to find the nature of the stationary point. So to find the nature, you need that table. So x, f dash of x, and then the shape. Right, so for x equals to, there's only 1, so you just need to find x equals to 0, and then f dash is 0, obviously, so then the shape would be horizontal. Okay, now you want a value lower and higher, so minus 1 and 1, the most natural thing. Let's find f dash of minus 1, and that would be sub into this equation there, so that would be 1 minus e to the power positive 1. Alright, let's reason it out. This one would be 1 minus e. What's e?
It's gonna be negative.
It's going to be negative. Yes, it will be less than 0, right? Because E is more than is about 2.7. So roughly 1 minus 2.7, which is negative 1.7, is less than 0. And then f dash of 1 would be 1 minus e to the power minus 1. Right? So I should put this one first. It will be less than 0 and shape is negative. Alright? So f dash of 1 would be that, which is 1 minus 1 over e. Now 1 over e is 1 over 2.7, which is about 0 point something, and that's why it will be more than 0.
Yep.
Right? 1 minus 0 point something is still more than 0. So more than 0, that will look something like that. Therefore, final answer, position in nature stationary point, minimum at, or you can write local minimum at 0, 1. Okay, and that's the only stationary point that we have in this shape here. Only stationary point. Okay, next would be find if there exist the equations of any asymptotes. Okay, now this is the new one.
I don't know, I have not heard that one.
Okay, so what does asymptote means? Okay, line, the definition is asymptote is the line that the graph approaches as x tends towards positive infinity or x tends towards negative infinity. And this is the definition you need to know in order to find this. And this is actually part of math methods. Yeah, it's understanding asymptotes actually part of the methods curriculum for sure. Okay, so let's have a look at the equation. So fx equals to, let's see, for question B, f of x is equals to x plus e power minus x. Let's rewrite it 1 over e to the power x. Okay, so let's say y equals to that. Right, let y equals to that. Oh, I'm just going to use fx is fine. Alright, so let's analyze it. As x approaches, let's see, negative infinity, right? Does fx approach a certain value? So negative infinity, think about it that way, right? You've got x plus 1 over, let's just say put negative 1000, right? Negative 1000 and then 1 plus 1 over minus 1000.
Yes.
Oh, sorry, it will be e to the power minus 1000.
Yeah.
Right? And that actually turns into plus e to the power 1000. So it actually turns into a really, really big number. Because look, this is much bigger than this, right? It rises, so this one is an exponential, it rises much bigger than just a linear minus 1000. So actually it also tends towards infinity. So fx will also tend towards infinity. Right? It means that as the graph, as x goes to the left, the graph will tend towards infinity like that. There's no asymptote. Right? Now, as let's see, as x tends towards positive infinity, let's see what the equation is like. So let's just try 1000 plus 1 over e to power 1000. Now, what does this one tend toward? This one will be approximately 0.
Yeah.
Right? Make sense?
Yeah.
Okay. So then let's say, so f of 1000 is just equals to roughly 1000.
But how do you find the asymptote?
Wait. So as x tends towards infinity, and let's say f of like infinity, it doesn't make sense. Okay, this is not something you can actually write in the exam. I'm going to write it this way. As f tends towards infinity, you would get like some sort of really big number, some infinity plus always 0, right? Because 1 divided by a really big number is 0. And so you see this one, so fx, right? So fx is essentially just the same as x. Right? Does it make sense? Let's say the equation is let's put y for example, right? So y is will be the same as x. Because as it tends towards infinity, this 1 over would tend towards 0, and this one would tend towards whatever. So as this one goes towards infinity, then this one would be basically the same as that. Does it make sense? So the asymptote would be Yeah, just y equals to x. Don't know how else to explain this. So asymptote is y equals to x.
Wait, can you say it again? Why is it y equal to x?
Because so this is the equation, right? So if you were to analyze this equation, when x tends towards infinity, right? So when x goes towards infinity, this component becomes 0.
Yeah.
Right? It will be closer and closer to 0, but it's not exactly 0. Does that make sense?
Yeah.
Yeah, it will be like 0.00000 something. So then the y value is very close to the x value, but not the same as the x value. Right? So that's the definition that asymptote, that the line that the graph approaches. So it gets closer and closer, the y value gets closer and closer to that value, but never equals to that value. Right? So see this one, it gets closer and closer to x plus 0.000 something, but never equals to x, because this component cannot be equal to 0. This is never 0. It only tends towards 0. Right? Because it tends towards 0, then y will tend towards being x. Just x. Like close to the value of x.
Yeah.
And that's why the asymptote is y equals to x.
Alright.
Yeah? As y approaches x, since as well approaches x, put the reason there. Y approaches x as x tends towards infinity, the 1 over e to the power x tends towards 0. Something like that. It's quite hard to explain these ones, but I think as long as you get the asymptote, it should be okay. Yeah, some sort of explanation. If it makes sense, it should be okay.
Yeah.
Okay? Last one. Sketch the graph of y equals to fx. Well, if you didn't get question B, you wouldn't be able to get question C. So basically question C, so note that we know that as x tends towards negative infinity, it will go towards like positive infinity, right, for the y value. And then we have a minimum point at 0, 1. So let's put the minimum point here. Is it 0, 1? X equals to x equals to 0, y equals to 1, which is on the y-axis here. All right, this point is 0, 1, and then you got to draw the asymptote. This is the line y equals to x. It's just a diagonal line. All right, so then the graph would tend towards that line as it goes towards positive infinity. Won't touch that line, and then as it goes towards negative infinity, it will just keep on rising forever. Yeah, so that's the shape of fx. Okay, so you get the map for like showing the line, approaching that, and then the minimum point. Yeah, pretty tricky. Yeah, this is definitely one of the harder ones. Yeah?
I think that was the hardest one, if we don't know about
the asymptote thing. That's why, and hopefully you guys learn something new doing these papers. Okay, question 7. When a liquid is placed into the refrigerator, the temperature T is given by that. Initially 100 drops to 40. Easy. Initially 100 means big T equals to 100 as small t equals to 0. When you look at the equation, right, when small t is 0, that whole thing equals 1. So you get 100 equals T0. Makes sense, right? T0 or T0 is always the initial temperature. So you can write straight away, T0 is equal to 100. Okay, and next you've got the drops to 40 in 5 minutes. So drops to 40 in 5 minutes, so you've got 40 degrees equals to 100 e to the power minus 5k. And we've got to solve for k. 40 divided by 100 is 4 over 10, which is 2 over 5 equals to, well, maybe let's just write it 40. Over 10 equals to e to the power negative 5k. Simplify that, you get 2 over 5 equals to e to the power negative 5k. ln 2 over 5 equals to negative 5k. Alright, divide, bring it to the other side, negative 1 over 5. ln 2 on 5 equals k. Alright, so then from this point I would write the equation so far that we know, which is t equals to 100 e to the power minus 1 over 5 is plus 1 over 5. So I'm just going to just write positive 1 over 5 ln of 2 over 5 times T.
Yep.
Yeah? Temperature of the liquid after 15 minutes is essentially at small t equals 15. What's the big temperature? 100 e to the power. So that would be 15. So 1 over 5, I'm just going to write it normally and then times by 15. Now I just gotta simplify that and that. 100 e to the power, so that would be 3, right? 3 ln 2 on 5. If you stop here, you wouldn't get the full marks. Okay? Because note that when you have ln in the power, you can simplify it because remember e to the power ln a is just a. Alright, so this is something you need to remember and recognize in this question. So then you would get something like, and how do we get ln of just something? Well, right now there's a 3, so you want to take this, put it in as a power. Okay? Right, this is a little bit of a tricky algebra, but you will get then ln of 2 on 5, everything power 3, right? ln of this whole thing. And then that would just be 100 times 2 on 5, everything power 3. Right, because e power ln a is just a.
Yeah, I got that one, but for 3, I got like negative 3.
Should be positive 3.
Because it's like negative k.
Negative k, yes, and k is negative. So negative of negative is a positive.
You see my one? Like,
Yeah? Yeah, k is negative, right?
Yeah.
So when you put it into the power, it's negative of
It's
1 over
k.
negative 5.
Okay, yeah.
Yeah, so it should be positive. And that means you would lose a mark for the second half, the whole second half. And this one, you can actually simplify this. It's actually quite simple. It will be 100 times by 8 over 5 power 3. Now, the reason why I write it as 5 power 3 is because you can actually simplify this before you can even work this one out. So 100 is, so note that 5 power 3 is just how many, there'll be 5 5s, right? And 100 is 4 times 25, which is 4 times 5 squared. So if I simplify 105 power 3, this one here will be 4 and this one here would just be 5. Alright, so that's the quick way of doing it. The slower way is to do equals to 4 times 25 times 8 over, and then you break this one into 5 times 5 squared. And 5 squared and 25 the same. So simplify. That would just be 32 over 5. Right? And you can actually work it out. You can leave it be work it out. But if you were to work it out, times both top bottom by 2 is 64 on 10. And the final answer is 6.4. Very convenient value because they ask you for the temperature, right? So it's 64 degrees Celsius. That's the final answer. Okay, make sense? All right. Last one is the hardest question. This is normally the last question is almost always a complex unfamiliar. Okay? They normally never put a CU question at the beginning. So yes, this one is a complex unfamiliar, chapter 9G, question 9. The acceleration of a lift is given by that. At time t equals to 0, the lift is passing the 50th floor with the velocity of yada yada. All right, let's see. Acceleration equals this. All right, at t equals to 0, it's passing the 50th floor given this velocity. Hi, what can we do? If we're given acceleration, we can find velocity. Right? So let's write out what we know. A equals to 1 over 9 t minus 5. And so then velocity would just be antiderivative of this thing with respect to t, right? Yeah? Take out common factor, the constant factor 1 over 9. Let's keep going. 1 over 9 antiderivative of t minus 5 dt. It's a lot easier. Alright, so then that would be 1 over 9 and then times by 1 over 2 t squared minus 5t. Okay? Alright, let's see. Placido. Okay, now at time t equals to 0, the lift is has a velocity -8. So this is v. Sub t equals to 0, v equals -8. Then note that when you sub 0 in, that one is 0, that one is 0. So 0 minus 0 is 0. This whole thing is 0. Now, which means that v equals -8 equals to 0 plus c. So c is just -8. Therefore, you've got so far v equals to just 1/9 times 1/2 t squared minus 5t, like so. Okay, so that's the actual velocity, right? Okay, let's see. At this point, you can, when I see this, right, I normally want to take out the fraction there because there's already a fraction at the front. But look, even if you don't want to do that, then you got your position is antiderivative. I'll just quickly take this one out first. 1/2 t squared minus 5t dt.
Yep.
Okay, so x would be 1/9 of, okay, let's see. So that would be t cubed, so 1/6 t cubed minus 5/2 t squared. All right, plus c.
Yep.
Okay. How do we find c?
C.
Mm-hmm.
Is it for the displacement?
Yes. How do we find the initial displacement?
Oh, so 300 is 6 times 1.
Yes, that's right. The 50th floor. So if x is the position relative to the ground, right, you have to define it as the position relative to the ground. Or if you define x as, okay, position relative to the 50th floor. Okay, this is the unfamiliar part. So we don't define it based on the ground. We define it as a position relative to the 50th floor. So then we've got at t equals to 0, x equals 0.
Yeah, that's what I thought.
Yeah? Oh, right. That's what you thought, right? Relative to 50. Oh, good. Okay. Because some people, they'll be like, oh, relative to the ground. Yeah, but no, this is a smart one to define it relative to 50th floor. So then you got 0 equals c.
Yeah.
All right, good. So then you got x equals to 1/9 times this thing, t cubed minus 5/2 t squared, and then plus 0. That's it. Okay, now next is find the floor at which the lift will stop. This means velocity equals to 0.
Yeah.
Right? So okay, so I might need the space over here. So continue up here. Okay, at v equals to 0, then you get 0 equals to whatever that equation is. 1/9 times 1/2 t squared minus 5t. Divide both sides by 1/9, it's gone. So then it's just got this thing here. Alright? It's actually not quadratic formula, Peter. Let's take out the common factor t. Half t minus 5. Therefore, t equals 0, or half t minus 5 equals to 0. So half t equals 5, t equals 10.
Yeah.
So it's on the ground when t equals 10. Right? Because it starts from the ground, right? Because at t equals to 0, it's passing through the 50th floor.
Yeah.
Oh wait, find the floor at which? Oh no, yeah. So we don't want when it's passing the 50th floor. We want 10 seconds later. Wait, does that make sense?
Yeah.
Hang on. V equals -8. Oh right. Sorry, I missed something. Yeah, I was like, wait, that doesn't make sense. Yeah, I missed a -8 there. Because c is -8.
Yeah, so
Yeah. So yes, no, you were right. It is the quadratic formula. All right, let's fix that one up. Not too bad. So, okay, yeah. Then you have to multiply this one in here.
That is terrible right there.
Huh?
That's just terrible. Like it's 1/9.
Yeah, 1/9. So that would just be 5/9. Yeah, and then -8.
Here I am.
Yeah. Okay. Look. Yeah. That's right. So at least you got up to this one, right? I'm just going to fix up the answer here. -8 dt. So then it would be, whoops, my bad. So then that would be 1 over, yeah, wait. So V would be t squared and then, oh yeah, t cubed, okay. So 1 over 3 times 18, right? 30, 50, that's 54. T power 3 minus 5 over 18 t squared minus 8t. Did you get this one? Was it the same as what you got?
No.
What did you get?
I think
Hang on, acceleration, yeah, acceleration is t, so velocity would be t squared, and then the one above would be t cubed. Yeah, it should be t cubed. Oh, you haven't found the position.
yeah, I haven't found the position.
Yeah, okay, yeah, you haven't found the position yet. Okay, so you're just solving for V, which is fine. So basically that is a position, so 0 to C, so yeah, I'll just quickly use the position equation here. 1 over 54 t cubed minus 5 over 18 t squared minus 8t. Alright, anyway, so we use the velocity equation, which, yes, you are correct. It is the harder version of it, which is 1 over 18 t squared minus 5 over 9 t minus 8. Alright, so now because we have the now we have a constant term, it's not the easy one anymore. You need to times 18 to both sides, right? Yeah. To get rid of the 1 over 18 here, times 18, so that would be t squared, and then 18 times 5 over 9, so I'm just going to quickly work that out here. If you got like 18 times 5 on 9, just cancel out these two, that's 2 times 5, which is 10, minus 10t, right? You gotta do 8 times 18, that's 80 plus 64 is 144. Okay? Alright, let's have a look at this one. What are the factors of 144? So ACB table. ACB. AC is negative 144. Right, 144 and B is negative 10. Okay, let's see. 144 is 12 times 12, which is 2 times 6, 2 times 3 times 2, and this one is the same. 2, 3, 2. Alright, how do we combine so that one is negative, one is positive, and then the difference is 10. Okay, let's see. Group these ones. Let's see if that will be, no, that won't be, that will be too big. Let's say group these two. Right, so 8, 3, 24, and that would be 6. Nope, that's too much. Let's group these ones together, all the 2's first, and that would be 2, 2, 4, 16.
Oh, 6. Oh, is it? No,
no, still not quite right. So we've tried grouping these 3. How about group these ones? 9 to 18 and 2 to 2, 8. Yep. This is the combination.
Yeah.
Okay, or you can use the quadratic formula. It should give you the same answer. You should get like square root of a nice number as well. But if you can find it out, that would be negative 18 and 8. So then 0 equals to t minus 18 times t plus 8, right? Because mode quadratic, so you can get straight here. So then t equals to 18 or 8. Yeah. Right? And here you would see that, negative 8. This one is rejected. Okay, which means the only answer is t equals 18. Yeah. Right? So this is the time when the lift will stop, and so you will sub t equals 18 into this equation here. Alright, now so then x at 18 would be 1 over 54, 18 power 3 minus 5 on 18 times 18 squared minus 8 times 18. Don't despair, you can simplify a lot of this. 18 times 3, remember we did that before? 18 times 3 is 54, right? Yeah, remember 18 times 3 will be 4 and then 2, that will be 54, right? Which means you can cancel that out, that will just be 18 squared, right? And 18 squared and 18, you can cancel that out, it's just simple 18. Minus 5 times 18, minus 8 times 18. Don't work it out yet because take out common factor again. 18 minus 5 minus 8, that's a lot easier to work with. It will just be 18 times 5, which is 90. Yeah. Okay, so the position is 90 and, can I write? Yep.
5 or 6.
Yes, so the number of floors, the number of floors would be 90 divided by 6, that would be 15. Right? And it's passing through the 50th floor, find the floor at which the lift will stop. So note that this one, it will pass through 15 gaps, right? Dot, 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 15. Okay, this one would be 15 like floor levels. So note that when you pass through 15, you think it stops at 40, was it 35? Or was it, hang on. The answer is the 29th floor, hang on. What do we get? Each floor spans a height of 6 meters. Oh, sorry. I think we did something wrong. 5 times 8 is 40.
Yeah, it's
90. 1, 5. Oh, yeah. What is the answer to 29th floor? So that should be 20 floors. So that should be 120. Yeah, wait. T squared, TQ minus 80, yep. 18 by, wait, hang on. Is it 18 by 8? Okay. Let's just use the quadratic formula for this one, just to be safe. So then T would be minus B, which is 10, plus minus B squared 100 minus 4AC, so that's plus 4 times 144 over 2A, which is 2. Okay, yeah, let's try the quadratic formula, because in the exam at this point normally you would panic and like, oh, I don't know what factors of 144. So 4 times 144 is 4. Okay, I think this one is something that you actually have to work it out. 16, 17, 5, 7, 6. So that would be 100, that would be 676 plus minus square root 676 over 2. All right, we want to guess what is the square root of 676. Okay, let's see. 200 squared is 400, right? And then 220 squared is 400, 30 squared is 900. So it's between 20 and 30. Okay? For it to end in 6, I would guess it's 26 or 24. Let's try 24 times that. So that's 4 is 16, 1, 9, 24, 48, 5, 7, 6. What is it? Oh, no, sorry, 6, 7. Sorry, that should be 5. Oh, no, that should be 48. 5, 7, 6. Okay, let's try 26 and 26. That would be 6, 6, 36. When the 3, 12, 15, 5. Oh, yeah, there you go. 6, 7, 6, that's 26 squared. So that will be 10 plus minus 26 over 2. Yeah. Okay, simplify that. 5 plus minus 13 over 2. So we know we want the positive version. So yeah, it is 18. T equals 18. 5 plus 13 is 18. I did the calculation right, which means I probably did the position wrong. Okay, let's see. Antiderive. Yep, the V is correct. That's the only way we could solve the equation. Minus 5 over 18. Yep, okay. And then minus 80. Yep. Sub 18 with that and cancel that out would be. Right. This is 1 over 3. Sorry. This is 1 over 3 because 54 cancel with 18 still leave you 3. My bad. Okay. Then you take out 18. Then this one is not 18. This one is actually 18 over 3. Yep. Which is 6. Yeah, okay, that makes more sense. So that's 18 times 6 minus 5 is 1 minus 8 is negative 7. Yeah, that's right. Okay, that's better. So that would be, yeah, well, let's just leave it as negative 7 times 18 because we know that we need to do this thing over 6. So that will be negative of 7 times 18 over 6. Cancel this one out. Right, so that would be 21. Yeah, that's right, 21. So it's 21 gaps instead of 21 gaps down because minus 21, right? Then you will land at, yes, that's right, 29th floor.
Alright.
Yeah. So minus every floor, you would get to 49. Minus 1 floor is get to 49. Minus 1, minus 1, minus 1. If you minus 21, it's just essentially get this to 29th floor. So final answer, 29th floor. Yes, definitely not easy at all. This is why a complex, unfamiliar question. Okay, every single mistake you make is brutal. Alright. Yep, that is it. I will upload this recording. And good luck going back retrying these questions, okay? So you gotta retry these complex unfamiliar questions. That's the only way that you can get better at complex unfamiliar stuff.